In this video, we're going to explain demonstration 1. And in demonstration 1, there's an iron 3 solution that's at equilibrium. So it's got a yellow iron 3 ions along with some colorless thiocyanate ions and some reddish brown complex ions. And so this equilibrium system is a blend of those two colors. Because it's at equilibrium, it's not just pure pale yellow, it's not really just reddish brown, it's a blend of the two things. In our first test tube, what we've got is we are going to add iron 3 nitrate solution. So iron 3 nitrate solution has iron 3 ions and nitrate ions. The nitrates in this case are going to be spectators, but the iron 3 is a reactant. And so by adding that reactant, this solution will become more pale yellow, or pardon me, sorry, not this solution. This solution becomes paler yellow at first, but then it uses that extra iron 3 up by shifting the reaction this way, and it becomes a much darker reddy color. And so by adding a reactant, the iron 3, this equilibrium system gets back to equilibrium by using that up and producing the other product. So it shifts to the product to use up the extra iron 3s. In our second test, what we do is we add hydrochloric acid. Now, hydrochloric acid has hydrogen ions and chloride ions. Neither of those chemicals are present in any of the reactants or products directly, and we'll see that there was no real shift in equilibrium here. Neither of those things are participating in this reaction, and they haven't caused an effect, so they must not actually be reacting in some way. But just because it doesn't look like it's part of the system doesn't mean it can't affect the system. So this is an example where we've added something that isn't directly listed, and also doesn't affect the system. In the next one, we will add something that is in this system. So we're going to add potassium thiocyanate, and potassium ions are there, and then SCN negative, the thiocyanates, are here. So we're adding a colorless chemical. We would expect that, normally with our basic understanding, you're adding something colorless, it'll make it a little bit lighter color. But what's happening here is by adding thiocyanate, the equilibrium system is disrupted, and it goes to produce more of the product. So this becomes a more reddish brown color because the equilibrium is shifted from the reactants to use up the excess thiocyanate. Now, in our last one here, we're going to add sodium hydroxide. And sodium ions are here, hydroxide ions are here, and we don't see any of those chemicals in the reaction statement, right? So I don't see sodiums or hydroxides. So maybe it's going to make no difference to the color because of that. But what's actually happening here is this will become a little bit lighter. It's a little hard to see in this, but this is a little bit lighter. And the reason is that this reddish brown color is going to get used up slightly because what happens is the iron 3 ions that are aqueous react with 3 hydroxides that are aqueous, and they produce iron 3 hydroxide, and that's a solid. And so what we're doing is we're removing some iron 3, and it shifts the equilibrium this way. That's really tough to see, but if I'm given a chemical that's added to an equilibrium system, I want to really pay close attention to, is it possibly making a precipitate that pulls something out of solution, right? Because this isn't an equilibrium system. We're removing iron 3s by making that. So that's our first equilibrium system. We'll look at the next equilibrium system in the next video. Please watch the actual demonstrations of adding the chemicals. I wish that you could be doing this experiment, but short of that, at least watch them and see how the color is changing and maybe try to visualize what that might look like in a graph.